Good afternoon to everyone. Continuation of our image processing syllabus, which we have very good knowledge about our image processing. So that knowledge which we are going to be keep on to connecting one topic to the other topic. So we are connecting while we are explaining the topics wise the complete syllabus. We are going to be cross-check our knowledge. So we wanted to acquire such a knowledge from image processing syllabus. So you must have to gone through one more topic which we named as image thresholding in image processing. So such a topic is one of the important topic. Okay. So image thresholding in image processing is the topic which we are going to be discussed right now. So let me to question why we want to concentrate such a topic actually. The topic which we named as image thresholding in image processing, usually we used to concentrate such a topic which we can understand immediately. Thresholding means it is a desired value of the used for the image processing. So such a desired value, how can you define? And if you suppose you maybe start to think why we want to define it. That means what is the major significance of this threshold value in image processing. So we are going to have the simple solution, simple answer such a question based on the drawbacks of segmentation. As we have idea about segmentation, which we discussed in the earlier class about segmentation, we used to say within the 2 or 3 words about segmentation. Segmentation is a subgroups of the image values which we are going to be used for the finding of pixel intensity value while comparing one pixel with the another pixel of the image within the image. That is standard image. As we have very good standard images, number one maybe in terms of JPEG we use Lena image. When we concentrate about the PNG image, which we are concentrating about cameraman image. Okay, so from such images we want to concentrate in terms of comparison of one pixel of intensity with another pixel of intensity, where we are finding any redundancy in the image. Okay, so how we may be compared? What is the comparison with whom? The comparison of based on what value you are comparing one to other is here. So such a comparison purpose, here we are using one of the image which we are using a general image and which we consider as a original image is smoothed by 5 by 5 moving average mask values based on the threshold. So we're going to have that smoothing image which we are comparing one part with another part. For example, you are using 45 degrees mask image which is here. Okay, so in this image, while you are comparing one value with another value, is there any redundancy in the image processing? We are basically concentrated. Okay, such a concentration we may be missing here. On what basis we want to compare? Of course, we may go ahead by the help of a simple concept which we know in the earlier class about mask, that is based on the smoothing image values of 5 by 5 moving average mask first process. But here we have to fix the threshold. That's what we are going to be use. One of the significance of comparison value is right now defined based on the knowledge of image processing. So that's what starting itself I told you. So here we are using your knowledge which we already have from the image processing knowledge. Based on that knowledge, we are defining the threshold. So what is the definition of threshold? Here we are using simply we are going to be defined about threshold in terms of simple thresholding, adaptive thresholding. So here adaptive thresholding we also call as automatic thresholding. So automatic thresholding value which we are going to be defined, in terms of your required in the sense while you are processing image processing application, you may be define it, and once you define it, it take automatically. Let me see the difference between this one after define the threshold. So you are going to be see the threshold. Image threshold means the most of the algorithms involved in establishing threshold level of certain parameter, which we named as connecting with the threshold lead to better segmentation. So the segmentation drawbacks will be minimized, but segmentation principle will be better improvement. So how it can be based on the thresholding we are going to improve. So that is what we want to concentrate here. So the using, how can you improve that? By using the samples of image intensity available, appropriate threshold should be set automatically in a robust algorithm. So no hard wiring of gray levels, because you are using gray levels in this sense because of this image which we are consider image is grayscale image. What is this? Grayscale image. So being it is a grayscale image, we are concentrating. So we are going to improve the significance of the process, significance of the segmentation process. Let's once you understand about a simple threshold value which we are using as a image threshold for improvement of segmentation process, let me see what does it mean adaptive thresholding. Nothing but automatic thresholding. You generally use of one or more following important factor points which you are using here: intensity characteristics of the object, okay, size of the object, fraction of image occupied of the object, and number of different types of size and probability occurrence and most popular image objects, intensity distribution estimated by using the histogram computation. So which we are going to be have towards to define adaptive thresholding or automatic thresholding. So let you see take that principle of information which we are defining in terms of threshold, adaptive thresholding or adaptive thresholding. Here we are using p-type, the p-type method. That is the percentage of image pixels, then they set a threshold t. Threshold value is t, such that your p% of pixels have intensity below t value. How in this sense? Let us take this is x-axis is your intensity, y-axis is your occupancy of the number of pixels within the image, where you are going to keep on to understand that pixels values in terms of percentage, and that percentage which we are comparing with intensity here at this level is low, at this level it may high, at this level is low, but where you, up to which one you want to compare. So we fix the threshold. So based on this image of comparison value, we may define your required application achievement. Okay, so that means the iterative thresholding successively refers an approximated threshold value to get new value which participates the image better by using this formula. What is this equation? This equation is so partitions of the better image better in the process of segmentation. So where we are going to use the two values, that is mu1 and mu2. So 1 by 2 into mu1 plus mu2 is we are going to define your further threshold value in terms of approximation only. How that we are going to be defined? Let us take one example, intensity thresholding. So you are keeping this is the image, okay? This is your standard image which you are taken through your digital camera. We call as a sensor. So that image we are keeping on to connecting in terms of threshold value that we have defined and fixed at 102. Your threshold. How you define this T value? Based on the knowledge of image pixel and the intensity of the pixel relation. Based on that, we define the T value, that is threshold value. So, based on this threshold value, you are going to proceed to understand one by other, that is, this image which you have objective function that we defined the automatic threshold value based on the objectives of the images only. So, that objective function is with respect to x and with respect to y. You know, the meaning of x and y here has a relation in between intensity and the pixels. What is the x? Intensity of the image, intensity of the pixels. What is the y? It is the number of pixels occupancies within the image. Okay, so let me take that converting your f of x y to f of x comma y to g of x comma y. That is, when equal to 1, your threshold value is greater than t. When does not greater than t, that is threshold value not greater than t, then it automatically 0. That is what we fix it. This is the formula which we are using for the comparison of your threshold value. You know the relationship, that means comparison of one pixel of intensity with the other. So by the relationship of x and y, how we used that comparison is this form, what we call this curve. Okay, so similarly we are using here such a process we are defining. But point is here, your values of pixel intensity distributions also we are concentrating by using one of the method which we call as histogram. So this histogram is the technique, is the method which help us to understand towards to define your what we call the intensity distribution from one pixel with another pixel. So you are fixed at 102, that is 102 here. This is t equal to 102. Okay, so you know the pixel values are changing from y-axis, intensity value of the pixel is changes by x-axis. So after you are processing this comparison, you got very clear value which is redundancy of the image values will be reduced and more clear, that is more significant threshold values of image attained. So next, you want to see much more on improvement of your threshold value based on the intensity distribution finding method, that is histogram. So we call it simply basic global thresholding. How we define basic global thresholding is based on the histogram of an image, partition the image histogram using single global method, single global threshold method. Okay, t is nothing but your threshold value. X-axis always it have what it have, intensity of the values. Y is nothing but always it has number of pixels occupancies within the image. Okay, and we compare one to other based on the relationship one to other. We compare and we find your intensity distribution value within by using threshold, by using histogram. Let me take other type of image which we call as one of the example is here. This example will help us to understand about the relationship in between pixel and pixel intensity. So by the help of threshold value t. So we keeping t value within the what we called midway between the maximum and the minimum gray levels. What is the meaning of gray level? It is a black and white image. It is a grayscale image. Grayscale image. Okay, grayscale image. Okay, so that grayscale image which we are going to be keep on to the your connecting towards the determination of your intensity distribution and as well as you finding any redundancy in the image while comparing with one image with the other Next, coming to this image thresholding in image processing, we usually used to have one of the very important application that we called as law enforcement application. Law enforcement application in the sense mostly that the documentation process, yeah, at any revenue office, they used to process by the help of some footprint, that is thumbprint. So by taking this thumbprint, we are processing one pixel with the other. That means one person thumb comparing with another person thumb, where we are comparing together and finding the which one is correct information. So for that, we are also using based on the threshold value. Based on the threshold value. So we keep the threshold value is here either what we called 100 or 152. How we keep either one out of 255 in the sense based on the knowledge of the image processing, where we are processing by the help of segmentation process. Without that knowledge, we cannot define this threshold in terms of either simple threshold value or automated threshold value. We cannot define. If we want to define that, we can define based on knowledge of the image processing, where we apply the segmentation. For example, global thresholding we are considering here. That global thresholding is nothing but we taking in between process, in between the pixel process. That means we call as T in terms of midway. What we call as midway between maximum and minimum grayscale. We taking this is the pixel, this is the image, it is grayscale image. Okay, this image is basically used in terms of your processing for the law enforcement application. So we'll find out suitably required data in easy manner by the help of threshold. So coming to the continuation of my previous slide, that is where we concentrate the sample or a simple thresholding compared with adaptive thresholding is used in senses with uneven illumination, where same threshold value not enable throughout complete image. But in such cases, look at the small regions in image, obtain the threshold for individual sub images, and the final segmentation is union of the region of sub images. So this we are a simple process. That means you are concentrating final segmentation process, but this final segmentation process happen automatically taking the threshold value. That's what we are concentrating. One of the important adaptive thresholding processes here. Okay, so this important point we should not be missed. So coming to the such a value, how we may be defined in terms of by consideration one of the major problem. So what is this major problem? Where your intensity thresholding is to be found in a good threshold level is by using bimodal histogram. That is effective for biomodal histogram. So simply we are processing that effective for biomodal histogram by in terms of algorithm we are going to be explained. So that means algorithm is nothing but step by step process. What is this first step? Step number 1 is going to concentrate on initialize your threshold value either in terms of sample threshold value or adaptive threshold value. So we will concentrate here. Such a threshold value we defined by the help of your pixel intensity with respect to your threshold value comparison. So T1 compare with T2, that is moving from step number 2 to step number 3. How we are moving in the sense average values which we are comparison not only in terms of greater than of T but also less than or equal to T. We are not missing. Why? Because we are defining such a good threshold level is nothing but in between maximum to minimum. Maximum and minimum values of your image which we are defining in terms of average. What do you mean average? By taking the T1 value T2 value, we are going to move the step number, we are going to move the step number 4 by taking the average value, that is T. So this value is not giving what we call the good threshold value, then we will repeat the step number 5. So this step number 5 will repeat, in the sense step number 2 onwards will be continued until up to you are reaching the good threshold level. So once you are using that, where you can process that algorithm in terms of best application is automatic threshold level selection. So this process is, we wanted to have very quick answer, very quick image processing by the help of, again, law enforcement application. The application is here, where concentration, law enforcement process. Okay, that processes we concentrate on the simple process. Okay, so such a value, we are again concentration in terms of histogram. Without histogram method, we cannot define the relationship in between pixel and its intensity. Okay. So coming to the such histogram, as I told you in a continuation of previous one, by the concentration on multi-level intensity threshold. Multi-level means T1, T2, T3, etc. Okay. So you may be taking the image and you separate that each and every process. Here your star is star. Here your circle out of which connected, which is your image, which is connected. What do you mean to understand this? So we want to subgroup by the help of segmentation. Okay, but that segmentation is nothing but subgroup of the images. But here, to define a particular part of image of the relationship in between pixel and its intensity, to give the quality of the image, nothing but avoiding the removing the redundancy. So we are concentrating the perfect image thresholdly in image processing. So by the help of, we can understand this histogram. So histogram table is nothing but, here we concentrate such a table. Very simple. You have defined 128 for this image, 96, 196, 122 we define. So based on the this value, you attain the you got this part of the image. Based on this threshold T2, you got this. Based on this 3, you got. So how we define this? By the help of histogram process. In coming class, we will discuss about histogram and its importance with certain problems and its solutions also. So coming to the such a thresholding process, let we are going to be have in detail about with another example which I want to explain to you. Here we are taking an image. Okay, that image, how you are subgrouping, and we subgroup. These subgroups are, you are going to be compared one with the other. By the comparison, with the help of threshold each sub-images using a threshold value 2.1, combine all the local threshold results, will attain the required image. That is what we are achieving, the threshold each sub-image independently also. So independent process is here automatic. That is what type of thresholding we are using here. What type of image thresholding is here is automatic. That is adaptive thresholding we are using. So another example I want to explain here. Another example is here, that is region-oriented image segmentation, which we are concentrating on region growing as well as region splitting and matching. So region growing based on threshold, how we are going to be connected, you can see here connected pixels, and the pixel P have its relation with neighbors. So that is neighbor is, what do you mean neighbor? We are comparing with one by another. So let we'll see this same application with one simple region growing algorithm. Okay, so you see here one image with another image which we are processing based on the your region based threshold value. That is first one. So this process is the one of the best process. By comparing P value we are comparing. So when you are comparing p value, what is the comparison is here? With the help of t, we are comparing each and every pixel values. While you are comparing, the redundancy is is going to be minimized. That is the repetition of the repeated pixel intensity values will be minimized. That is important here. That's will obtain the required image. That is one of the best application based on the reason growing based threshold algorithm process. So I'm also concentrating with other examples, which is samples of fingerprint and iris also. So sometimes you want to process with the same image, one subgroup by another. What do you mean to another compare to one by another? In the sense, based on your threshold value, your defined threshold value, you are going to be have your original image, original image, original image. Okay, so that you are comparing which one is original. That mean what I want to say with this example, by comparing together, which one is correct, which one is perfect, that we are finding. So how we are finding in the sense, even segmentation process also depend on wavelet packets also. That is subgroup, small packet. By the comparison of both, we are going to achieve your required image. So similarly, same thing we can apply wavelet packets and wavelet. Instead of wavelets here, we are using segmentation, but keep on, but along with the value of threshold, along with the value of threshold, we are going to be achieve a required. So here also same full color in models also we are comparing one to other based on the segmentation only, based on the segmentation and its threshold. Will achieve. So with this discussion, you can also refer our prescribed textbook, both especially JRAMBAN. You can go ahead. It's a very simple understand. You want to programming wise, you can go through this first textbook, but both are important. So with this, I want to close today our discussion, and we'll be continue in the coming class further with one more topic, and whatever we are missing in our discussion also will be discussed in the continuation of our class. Thank you so much for your patient listeners. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.